another integral that requires a substitution. So remember, the part of the integral that you're looking to substitute needs to have a derivative present inside the integral, at least up to a constant. So it doesn't have to be exactly there, but for instance, if you're going to substitute t cubed for something, you better have a t squared inside your integral. So here, when I think about whenever I think about performing this integral, I don't have a product rule. Right? There is no product rule for integrals. So we need to see if we can solve this with a substitution. And the substitution we should make is the t squared. Because when you differentiate the t squared, you end up with just a t, and you've got a 7t right there. So let's see that this is the right choice. If I create a new variable, now it's called smiley face, and I differentiate smiley face with respect to t, that's 2t. So then the smiley face is equal to 2t dt by multiplying both sides by dt. And I look at my equation and I need a 7t dt. So I need to turn this side into a 7t dt. I need to get rid of that 2. Right, so I'll divide both sides by 2, and then I'll multiply both sides by 7. There's my 7t dt. So I can replace the integral of e to the t squared times 7t dt as the integral of e to the smiley face, right? Because smiley face is equal to t squared. And then I can replace the 7t dt with a 7/2 d smiley face. That 7/2 is a constant. And what's the integral of e to the x with respect to x, or e to the smiley face with respect to smiley face? That is itself. Again, we have that constant of integration because I don't have limits on my integral. This is the indefinite integral. And we gave ourselves smiley face, so our answer shouldn't depend on smiley face. This is 7/2 e to the smiley face, which is t squared, plus c. So that should be the antiderivative. Let's double check. If we differentiate with respect to t, the 7/2 can move past the derivative. You're left with e to the t squared, and the derivative of the plus c is plus 0. So when you differentiate e to the t squared, you get e to the t squared, but then by the chain rule, you have to multiply by 2t. Your 2's cancel, and you're left with 7t e to the t squared, which is your original function. So that what we have here in a box is the family of antiderivatives.